Chapter 8, Homework 1, 8-7. Write the multiplier for each increase or decrease described below. Remember to start at 100%. Part A, if we start at 100% and we increase by 25%, that means we are adding 25%. For a total of 125%. Now to write a multiplier, we need this number as a decimal. So you need to move the decimal over 2 times and get 1.25. Basically what we do here is you convert a percent to a whole number. And if you forgot, the way you convert a percent to a whole number is divided by 100. When you divide this by 100, you get 1.25. It's the same thing as moving the decimal over 2 times to the left. The decimal thing is just a shortcut for this. Okay, D, a decrease of 94%. Remember to start at 100%. The decrease means we need to subtract away 94%. So 100% minus 94% is 6%. Now we need this number as a decimal, not as a percent. So we take the decimal point and we move it over twice. There is an empty space here which I'll fill in with a 0. So my multiplier is 0.06. 8-8. A particular sequence can be represented by this. Alright, so the first thing we do is we plug in 1, 2, and 3. What are the first term, second term, and third term? So to get T1, that's going to be 2 times 3 raised to the power 1. That's going to be 2 times 3, which is 6. To find T2, you do the same thing. T2 is equal to 2 times 3, and then replace n with 2, because it's the second term. So that number goes in for n. 3 squared is 9, so this is just 2 times 9, which is 18. Don't forget to find T3. Graph this sequence. What's the domain? So we have our first term, which is 6. I'm going to go by 2 here. Alright, so our first term is 6, so we find 1 on the x-axis and we go up to 6. The second term is 18, so here's 2, we go up to 18, and then 3, it's even higher. Now the domain is all the values on the x-axis, the list of possible inputs or x values. So we could have 1, 2, 3, 4, and so on. 0 is optional here. Sometimes 0 is included, sometimes it's not. But you basically just look at the numbers on the x-axis. Remember to write it with the curly brackets. You can't say 0 to infinity on this one, because the dots are not connected. So don't say 0 to infinity. Alright, I'll let you do C and D. 8-9. Solve each equation for the indicated variable. So for D, we're going to solve for t squared. Since there's a fraction, I'll multiply both sides by 2. We have 2 times g, and then 2 times half at squared. 2 times half is 1. So just 1 at squared, which I'll write just as at squared. And then you can divide both sides by a. And now we have solved for t squared. So t squared is equal to 2g divided by a. This is a times t squared, so the only way you can undo a times is by division. C, there's fractions, there's 2 fractions, and the least common denominator of 3 and 2, LCD, is going to be 6. So I'll multiply everything by 6. So we have 6 times x over 2. That's 6x over 2 minus 6 times 7 is 42 equals 6 times y is 6y divided by 3. 6x divided by 2, that's 3x minus 42 equals 2y. Let's solve for x. So to isolate x, I need to write this as x equals. So I'll start by adding 42 to both sides. And I'm going to have 3x equals 2y plus 42. And then if I want to get x all alone, I have to divide both sides by 3. So x is equal to 2y plus 42, all divided by 3. Now if you want, you can take this a step further and write x equals 2/3 y plus 3 goes into 42 13 times. You have that option. Okay, 8-11. For the triangles, determine if they are congruent, and if they are congruent, complete the congruent statement and state the property. What they mean by property is like HL, AAS, etc. Alright, let's look at C. This one's kind of tricky, so I'll just do this one. So for C, you notice that the triangles are touching. So that highlighted side, we don't know what the we don't know what the length is, but we know that it's shared between the triangles. So what we could do here is redraw the triangles separately, and then we should pretty easily be able to see what's going on here. So we have, this is F, it's D, it's E, and then we have A, B, and this one is C. So that's 7. And over here I could also have a side of 7. Then this side is 6. And we also have a side of 6 over here. And then this shared side is, this is the tricky part. So on the top triangle, it's right here. On the bottom triangle, it's right here. Since I don't know what that length is, I'm going to call it X. But I do know that this little piece of that side is 3, and this little piece of the other side is 3. So you can see that the sides are actually the same. Both have length 3 plus x. So yes, congruent. They are congruent. Answer is yes. There's the property, side, side, side. That's one pair of sides. Here's the second pair of corresponding sides. And then the shared side is the third one, because each one is 3 and x. 3 and x. Alright, so if a congruent statement would be ABC, that's the top triangle. Since we're going across side AB first, we need to go across side DE first, the other triangle, and it's DEF. (8-14) Sketch a general graph of the function y equals b to the power x. Give each of the following values of b. Okay, so A, b is larger than 1. So if a b is a number larger than 1, it just says a general graph. So when the multiplier is larger than 1, that means the function is increasing. When the number is between 0 and 1, when you're multiplying by a decimal, it's decreasing. And then I'll let you do C. 8-19, let's do A. Alright, so I have fractions. Let's find the LCD of 7 and 5. Well, if I just do 7 times 5, that's 35. So that's going to be our LCD. Then we're going to multiply both sides by that 35. Okay, so we have 35 times 4. That's 140x divided by 5 equals, careful on this side, you need to distribute the 35. So it's going to be 35x minus 70 and divide that by 7. So we've got 140x divided by 5. 5 goes into 140. Let's see how many times. 28. 5 goes into itself 1 time. So this is just 28x equals. Then we go over here. 7 goes into 35 5 times. So it's 5x minus. 7 goes into 70 10 times. Alright. So we take away 5x from both sides to get all the x's together on the left hand side. 28 minus 5x is 23x equals negative 10. And then to finish this off, we divide both sides by the number in front of x. So x is going to be negative 10 over 23. Alright, B's here a little tricky in that you need to distribute a negative number. So let's look at C. And distributing the negative 2, we get 6 minus. Yeah, a lot of people will start this off by doing 6 minus 2, which is 4. But that's wrong because you got to remember PEMDAS. This subtraction comes last. This multiplication, this distribution, that comes before. So let's distribute first. 6 minus 2c, and then negative 2 times negative 3 is plus 6. So remember, don't do the 4, don't subtract them first. That comes last in the PEMDAS order of operations. Alright, so we've got negative 2c, let's combine like terms. We've got a 6 and a 6, so that's negative 2c plus 12 equals 12. And then if you take away 12 on both sides, we get negative 2c equals 0. And then if we divide both sides by negative 2, c is going to be equal to 0. 0 divided by anything is still 0. Alright, E-25. Each table is an exponential function. Alright, so let's do A. We need to write our equation. Y equals A times B raised to the power x. So let's find out the multiplier. The trick is the multiplier. You can take the second term and divide it by the previous term. So if you divide these two together, it'll tell you what to multiply by. Alright, so let's get our calculator. 3.96 divided by 1.2. That's 3.3. Alright, so our multiplier is 3.3, and let's confirm that. If we take 1.2 and multiply it by 3.3, we get 3.96. And then if we take 3.96 and multiply it by 3.3 again, we get 13.068. And then if we multiply by 3.3 again, we're going to get 43.1244. And then if you keep multiplying by the multiplier, you'll get the fourth term, which is 142.31052. 142.31052. Alright, so then in our equation, that means our multiplier, the number raised to the power x, is 3.3. And then to get the starting value, you just look at the 0 term, and that's 1.2 times. So y equals 1.2 times 3.3 to the power x. 26. These functions all have the same multiplier. So it's the number being raised to the power x. And that number being raised to the power x is 2. Let's make an xy table for each of the functions, using integer values of x for negative 3 to 5. So we have negative 3. Integer means whole number. So they want you to make a table like this. And then let's start with this one right here. So if we do 2 to the power negative 3, That's the same as 1 over 2 cubed, which is 1 over 8. 2 to the power 3 is 8. Alright, then if we do 2 to the power negative 2, that's 1 over 2 to the power 2. Remember, negative exponent means you have to flip it, and then you change the little sign. And that's 1 over 4. If we plug in negative 1 for x, 2 to the power negative 1, that's 1 over 2 to the power positive 1, which is just a half. And if we plug in 0, 2 to the power 0, anything to the power 0 is 1. Okay, if we plug in 1, 2 to the power 1 is just 2 itself. If we plug in 2, 2 to the power 2, that's 2 times 2, which is 4. And then you can see it's multiplying by 2, so you can just continue the pattern. Times 2, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So that's our multiplier. Alright. For the next one, same deal, make a table. Alright, so if I plug in something like negative 3 to this one, I get 2 times 2 to the power negative 3. Well, 2 to the power negative 3, we found that out in the last one, so this is just 2 times 1 over 8. Multiplying straight across, we get 2 over 8, and if you divide the top and bottom by 2, that's a fourth. Alright. Now let's plug in negative 2. 2 to the power negative 2. We found that was a fourth, so this is just 2 times a fourth. Multiplying straight across, we got 2 times 1 over 4. That's a half. And you can continue on. You can notice that the multiplier also, the multiplier is 2. So you could just keep multiplying by 2. It's alternate strategy. A half times 2 is just 1. 1 times 2 is just 2. 2 times 2 is 4. Multiplying by 2. So you can see that these lists are similar. This one is like one term ahead. Like the fifth term here is 32. The fourth term is 32 over here. But it's the same pattern of growth. Don't forget to do the last table. Okay, we're going to sketch, for part B, we're going to sketch the 3 graphs. So starting at 0, 2 to the power x. Do this one in red. So 0, 1, 1, 2, 2, 4, 3, 8. And then if we go the other way, negative 1, half, negative 2, a fourth, and it never hits 0, it just keeps shrinking. So that's 2 to the power x. Alright, and then next we've got 2 times 2 to the power x. Do that in blue. So 0 term is 2, 0, 2. Then we got 1, 4, 2, 8. Coming the other way, negative 1, 1. And then it's the same pattern as the other one, but it's going to be slightly above. Don't forget to do this one. Similarities and differences. So right away I noticed one similarity is same growth rate, which is times 2. But a difference I notice is, look at the starting value. One has a starting value of 1, the other one has a starting value of 2. So there's 2. Maybe you can think of some more. But those are the two that jump out to me. 8-27. Wade and Dwayne were working together to write an equation for the sequence 12, 36, 108, 324, etc. Wade wrote this equation, and Dwayne wrote this one. Okay, so let's make a table for Wade, make a table for Dwayne. Alright, so we catalog the first four terms. Okay, so for Wade's equation, 4 times 3 to the power n, when n is 1, that's just 4 times 3 to the power 1, or 4 times 3, and that's 12. If I plug in 2, that's 4 times 3 to the power 2, which is 4 times 9, and that's going to be 36. If I plug in 3, that's 4 times 3 to the power 3. 3 to the power 3 is 27. And 4 times 27 is 108. So you can see it's going to match that sequence up there. Now let's check Dwayne's table. Alright, here's his equation. It's a little different. So it's 12 times 3 to the power n minus 1. So if we plug in 1, it would be 3 to the power 1 minus 1, which is 3 to the power 0. And anything to the power 0 is 1. So 12 times 1, that's just 12. Alright, now if we plug in 2, it's 2 minus 1, so 3 to the power 2 minus 1. That's 12 times 3. That's 36. Matches so far. Let's do one more just to be sure. 12 times 3 to the power 3 minus 1. That's going to be 12 times 3 squared. Or 12 times 9. If you multiply those together, that's 108. So it's going to match. Alright, so what do you notice? Same table, right? Different equation, same table. So how do you think Dwayne explained his method? Well, if you notice, Dwayne took the first term. And his equation. And since this is a multiplying by 3 table, you can get the 0 term by dividing by 3. 12 divided by 3 is 4. That's the same in both sequences. So it looks like Wade used 0 term. And that's the way we've been doing it in class. Okay? So maybe Dwayne said, use the first term instead of 0 term. And then he adjusted his equation by, instead of doing 3 to the power n, he does 3 to the power n minus 1. So that adjusts to compensate for the 0 term. So maybe that's how he described it. I'm not sure. But that's the major difference. Alright, so you can try C and D. Similar, but this is going to be for arithmetic. Okay, 829. Here's what we know. PQ is equal to SR. So I'm going to put a tick mark there. Then we have PR equal to SQ. Alright, and then because the triangles are touching, let me redraw these separately. might help you see it better. This is triangle SQR, and then this is triangle PQR. Because the triangles are touching on this third side, that's going to count as our third side. And we have SSS congruence. Okay, so what are we given? PQ equals SR. And what does that tell you? It tells you that line segment PQ is congruent to line segment SR, and that's by definition of congruence. Alright, then we have this that's given to us, PR equals SQ. Since they have equal lengths, therefore line segment PR is congruent to line segment SQ. And that's also by definition of congruence. Alright, this third side QR and QR, that's shared between the triangles. And so we'll write that as line segment QR is congruent to line segment QR. And that's what we call the reflexive property. Also think of it just as given. Alright, so once we know those three things, then we know the triangles are congruent. So I'll let you fill in the congruent statement. Triangle something is congruent to triangle something by SSS. 8-40, Dusty won a bunch of money on Who Wants to Be a Zillionaire. He puts the money into an account that earns this interest and plans not to use it until he retires. So let's write an equation that represents the amount of money Dusty will have in n years. Let's come up with our multiplier. As always, we start at 100%, and the account is earning 6.25% interest. So he's getting more money. The money is growing. So we're going to add that to the 100 for a total of 106.25%. Then to turn that into a multiplier, you shift the decimal to the left 2 times. That's 1.0625. Our starting value, or 0th term, actually I'm going to call it initial value here. What did he start with? 125,000. So we plug this into y equals a times b raised to the power x. Starting value comes first, so y equals 125,000 times the multiplier, 1.0625 raised to the power x. And it says n years. So let me say raised to the power n. How much money is in the account when he retires in 23 years? After 23 years, n equals 23. So y equals 125,000 times 1.0625 raised to the power 23. You plug in n for 23. Seeing as this is a PEMDAS situation, we need to do the exponent part first. Okay, so you do it to the power 23, and then you multiply it by how much money there was to start. So it looks like he's going to have $504,052.30. And we're going to round to 2 decimals because this is money. And let's do 43. So since I did that whole one, I'll let you work on 43. 8-44. If the triangles in the diagram are congruent, state which congruence condition can be used. If they're not congruent, say cannot be determined, then calculate x if possible. So let's look at A. So it looks like we have a side in common. And then this is 73, that's X. We have another side in common in the middle. And then we have an angle. So this top triangle, we have a side, angle, side. And then the bottom triangle is also going to be side, angle, side. So this is SAS congruence. Okay, so that means that this angle X is going to correspond to whatever this one is. Now that's nice. I also call this X because we could use our triangle angle sum theorem. 28 plus 73 plus X. These three angles should add to 180. 28 plus 73 is 101. So 101 plus X equals 180. And X equals 79. Alright, let's look at B. This is the bow tie, so those angles are the same. We also know that, put 2 tick marks on these. These 2 angles are common, so the middle angles are shared. The outside angles are going to be shared. Alright, and so that means this side, length 9, corresponds to that side, length 9. And what makes this one tricky is, even though they don't tell you this angle, you can figure it out. So if you call this middle angle like Z, we know that 23 plus Z plus, let's call this Y, equals 180. And then in the other one we have 23 plus Z plus Y equals 180. So we don't know that these are the same, so we can call it Y1 and Y2. So in the left triangle it's 23 plus Z plus Y1 equals 180. And over here we have 23 plus Z plus Y2 equals 180. However, if you isolate Y, so take away 23 from both sides, so that's going to be 157. And then if you isolate Y1, Y1 is 157 minus Z, subtracting Z from both sides. Then, looking at Y2, same thing. So taking away Z from both sides, this is actually 157. Whoops. You can see that Y2 is also going to be 157 minus Z, where Z is this bow tie angle. Because this is the same angle, that means Y1 is congruent to, angle Y1 is congruent to Y2. Alright, so what does that tell us? Well, let's clean this up a little bit. That means that these 2 angles are going to be congruent. If you know 2 angles in a triangle, you can find the third angle because it adds to 180. And then that means we could use AAS. 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 Alright, so this one was pretty tricky. Congruence condition is AAS, which means that X is 6. Alright, 846. Lisa is weighing combos of children's blocks. She didn't write down the weights, but thinks she remembers them. 4 blue blocks and 5 red blocks are 17 ounces. 1 blue block and 8 red blocks are 38 ounces. What's the combined weight of 1 red and 1 blue block? This is a word problem. So I can just set let B equal weight of blue block and let R equal weight of 1 red block. 4 blue blocks, 4B Add 5 red blocks plus 5r equals 17. 1 blue block, 8 red blocks weigh 38. So 1b plus 8r equals 38. And we have our system. Let's use elimination. Let's multiply the bottom equation by -4. So the top equation is going to stay the same. 4b plus 5r equals 17. And the bottom equation, whoops, that was going to be -4b minus 32r equals -152. Alright, so if we add these together now, the 4b's cancel, and we get -27r equals 152 minus 17. It's going to be 5311, -135. Alright, dividing both sides by -27, r is equal to 5. Alright, so what is the combined weight of 1 red and 1 blue block? Red weighs 5 ounces. So I'll let you find blue and then add up the red and blue blocks together. 8-51. We have a graph. Let's remember how this works. The number here is the input. You find this on the x-axis. So there's 1 on the x-axis. And then you have to come down to hit the graph, and you hit the graph at a height of -1. That's the corresponding y value. So basically it's saying when x equals 1, y equals -1. And then if you look at the coordinates of this point, it's 1, -1. So that makes sense. Here's your x. When x is 1, the y value at that point is -1. Alright, let's do another one. F of -6. So if we come and find -6 on the x-axis, we go up to where it hits the graph, and the y value right there is 2. Coordinates of that point are -6, 2. So the x coordinate is -6, y value is 2. 8-60. Assume that a DVD player loses 60% of its value. So that's a decrease. Suppose the additional value of the DVD player was 80 bucks. Alright, what's our multiplier? Well, for a multiplier as a percent, we need to start at 100%, and since we're decreasing, we subtract 60%, because that's how much is decreasing, so 40%. Moving the decimal over to the left 2 times, that's 0.40, or just 0.4 is fine. What's the value of the DVD player after 1 year? So let's make an equation out of this. This is going to be... Let's skip ahead to part C. V of t equals starting value, which is 80 times our multiplier raised to the power t. It's going to be 0.4 to the power t. Alright, so if I plug in 1 to this equation, that's 80 times 0.4 raised to the power 1. We do the exponent first because of PEMDAS. Remember that 0.4 to the power 1 is just itself, that's 0.4, and then if you multiply that by 80, 32 bucks. Alright, and after 4 years, we do 80 times 0.4 raised to the power 4. You plug in t as the number 4. 0.4 raised to the power 4. Always do the exponent first, PEMDAS. And then you times it by, you times whatever that is by its initial value. And we round to 2 decimals, so $2.05. So you can see that after 4 years, it's pretty much worthless. Alright, I'll let you answer D and E. 63. Find the midpoint. Seems like you guys understood that one, so I'll let you do that one. Alright. Justify. Are the triangles congruent? Yes or no? And justify means use one of those 3-letter congruence conditions. So looking at the first one, I see right away these sides are shared, and when a side is shared between two triangles, it's congruent. That's the reflexive property. Okay, so these two sides correspond, those two sides correspond, and then the side in the middle corresponds. So the answer is yes, they are congruent by the SSS congruency condition. Alright, if you look at B, this is the bow tie, and the angles in the middle are congruent. This is by a property known as vertical angles. It says that when lines are connected in this fashion, it creates two congruent angles. So we check for congruence. We have these two sides congruent, these two sides congruent, and these two angles congruent. So this one's actually going to be a no, because looking at the triangle on the right, we have a side, angle, side, SAS, and then the one on the left, we actually go in a different order. The angle's right here, and it goes side, side, angle, side, side, angle. So they don't match. Answer is no. Alright, C, another one of those kind of tricky ones. It's sharing part of a side. So if you split the triangles into two pieces, we know that these two angles are congruent. We know that these two parts were touching, so by the reflexive property they're the same. Those are going to match up. And we also know that the remaining part of each side was length 3. So that means this whole, if I call this x, this whole side length is x plus 3, and same for that one, x plus 3. So because part of their side was touching, and we knew the other parts matched, we could say that actually these two triangles have corresponding sides. Whoops. And last but not least, we have one more angle. This one and that one. They're corresponding. And so the answer to this one is going to be yes by ASA. And if you can't see that, here's the angle. Here's the side. Here's the angle. So angle, side, angle, in that order.